In this video, we'll take a look at section 5.1, which is rational expressions and functions. And what we're going to take a look at is multiplying, dividing, and simplifying these rational expressions. Now, our first objective is finding the domain of a rational expression or function. Now, first, rational expressions have the form r of x equal to n of x divided by d of x. Now, what this is saying is you just have one polynomial divided by another polynomial. So in other words, you have a fraction with polynomials. An example of a rational expression: t to the fourth minus 5t all over t squared minus 3t minus 28. This is an example of a rational expression. So as you can see, it's a fraction, but you just have a fraction in the numerator. You have a polynomial in the numerator and a polynomial in the denominator. Now, what makes an expression or function undefined? So we might have seen this before. What makes a function or expression undefined is whenever you divide by 0. You can't divide by 0. That makes an expression undefined. So what we're going to do is take a look at finding the domain of these rational expressions. And then we're finding the domain. What we want to do is figure out what's going to make the denominator 0, and then we exclude that from our domain. So here's the steps. Set the denominator equal to 0, and then solve the equation. The domain is all real numbers except those that make the expression or function undefined. So it's all real numbers except what makes the denominator 0. Okay. Let's take a look at an example. So find the domain of the following function. We have g of t is equal to t squared minus 9 all over t squared minus 7t plus 10. So all we're interested here is whatever is going to make the denominator 0. So let's go ahead, take the denominator and set it equal to 0. And now we have a quadratic equation. Well, solving quadratic equations, we already have one side equal to 0. Now let's factor. So we need two numbers that multiply to 10 and add up to -7. We could use t minus 5 and then t minus 2. Then you go ahead and set each factor equal to 0 and then solve. So we get t is equal to 5 and t is equal to 2. These are the values that are going to make the denominator 0. So our domain, this would be all real numbers except 2 and 5. So it would be everything except 2 and 5. These are the only two numbers that will make the denominator 0. These are the only two numbers that will make this function undefined. Another way that you could write out all real numbers except 2 and 5 is by using interval notation. So if you were to use interval notation, it would be from -infinity to 2, then parentheses, then union from 2 to 5. This is going to capture all the numbers between 2 and 5. Then union, and then from 5 to infinity. And that'll be our domain in interval notation. That's everything except 2 and 5. Let's take a look at another one. So find the domain of the following function. Okay, so let's take our denominator, set it equal to 0, and now solve this equation. So we have a quadratic. Let's try to factor it out. So I need two numbers that multiply to -28 and then add up to -3. I could use -7 and +4. And then if you go ahead and set each factor equal to 0, you got x equals 7 and then x equals -4. So our domain, it would be all real numbers except these two, except 7 and -4. Now writing this in interval notation, this would be from -infinity to -4, union -4 to 7, union 7 to infinity. And that's the domain of our function. So everything except 7 and -4. Okay. Now let's take a look at simplifying rational expressions. Simplifying rational expressions, what we're going to be doing is simplifying fractions. So in order to simplify these rational expressions, you're going to completely factor the numerator and denominator. Then you cancel out any common factors. Okay. Let's take a look at this first example, basic fraction. It's not polynomials in the numerator or denominator. We just have 128 over 160. So what we're going to do here is factor out the top, factor out the numerator, and factor out the denominator completely. Now, 128, I'm going to break this down into prime numbers. Okay, so I'm going to use a factor tree and break this down. So I can use 2 and 64. 64, I could use 2 and 32. 32, I'm going to break it down with 4 and 8. The 4 breaks down to 2 and 2, and then the 8 breaks down to 2 and 4, which breaks down into 2 and 2. Okay, so let me write this now. So 128, this is 2 times 2 times 2 times 2 times 2 times 2 times 2. Let me see if this, how many 2's do we have? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. So I completely factored out that 128. Do the same thing for 160. Break it down. I could break it down with 10 and 16 first. 10 breaks down to 2 and 5. 16 breaks down to 4 and 4. And now each one of these 4's break down to 2 and 2. So I have 2 times 2 times 2 times 2 times 2 times 5. So I completely factored out the numerator and I completely factor out the denominator. Okay. Now I know you've probably seen a different way to simplify fractions. You just go ahead and take a look and see what's a number that can go into both of these, and you can divide like 128 and 160 by that number. I'm showing you this method just so we could get used to how we're going to factor out these rational expressions. So now, once I have it completely factored, you start canceling out common factors. So I can cancel out these 2's, I can cancel out another 2, I can cancel out another 2, another one, and another one. Okay. So what I'm left with is 2 times 2, which gives me 4. And then denominator, I'm just left with 5. And now we have that fraction completely simplified. Okay. Let's take a look at a different one. This time let's take a look at like a polynomial with a variable. So simplify the following rational expression. So I have 7x squared over x. Well, 7 is a prime number. I can't break that down, so it just stays as 7. And now x squared, this becomes x times x. All over and then my x. So now when I begin to simplify, they have an x in common that I can cancel out. So I'm just left here with 7x. And now I simplified this rational expression. Okay, now let's up the difficulty. Now we have 6x squared plus 4x all over 4x squared plus 8x. Now this whole section, it's really just about factoring. Okay, so you'd be using a lot of the techniques that we saw in chapter 4. So let's go ahead and factor out the numerator and denominator completely. Okay, so let's take a look at the numerator first. Remember, always look for a GCF. So in this case, I have a GCF of 2x. So if I factor that out, I'm left with 3x plus 2. Now this 3x plus 2, I can't factor that out even for, any further. So it just stays as 3x plus 2. Now the denominator, I can factor out a 4x, and then I'm left with x plus 2. Now you look for common factors. Okay. Well, one thing that I noticed that they have in common, one common factor is x and x. I could cancel those out. And now with the 2 and 4, I could simplify that part as well, because 2 goes into 2 once, so it goes into 4 2 times. Okay. So what I'm left with now is 3x plus 2 all over 2 times x plus 2. Okay. Now be careful here. Even though you see like another x over here, another x over here, you can't cancel those out because those are not factors. Those are just terms. Same thing with these 2's. This is just a term. It's not a factor. So remember, factors are when you're multiplying. So now I have my rational expression completely simplified. So just be careful with what are factors and what are terms. Let's take a look at this next one. So we have 20a squared minus 80b squared all over 16a squared minus 64ab plus 64b squared. Okay, so remember, when you're factoring, always look for a GCF in the beginning. So in the numerator, I see that they have a GCF of 20. So I'm going to factor out that 20. I'm left with a squared minus 4b squared. Now in the denominator, first thing I notice is they have a GCF of 16. So I'm going to factor that out. I'm left with a squared minus 4ab plus 4b squared. And now you're going to continue factoring. So I notice I have a difference of 2 squares there. I can factor that out. So this now becomes 20 times. I'd have a minus 2b times a plus 2b. And now in the denominator, I have 16 times. Now this trinomial, this factors into a minus 2b times a minus 2b. Now I could cancel out common factors. I'll have an a minus 2b on the top and an a minus 2b on the bottom. So I could completely cancel those out. Now something else I have in common is with the 20 and the 16. Those have a common factor of 4. So 4 goes into both of these. 4 goes into 25 times, and then it goes into 16 4 times. So now we write out our final answer. We have 5 times a plus 2b times, or I'm sorry, all over 4 times a minus 2b. And now we have completely simplified this rational expression. So main concept here is really just factoring, using those techniques that we saw in chapter 4. You're going to factor out the top and the bottom completely, and then you cancel out whatever you see in common. Next, we take a look at multiplying rational expressions. So when we're multiplying rational expressions, so if you have a over b times c over d, you just multiply straight across. But then there was another way that we saw for, say, multiplying fractions. Let's say you have, for example, so you have 2 over 3 times, 6 over 7. Where as long as the two numbers diagonal, if they have something in common, you could cross cancel there. So for example, 3 goes into 3 once, it goes into 6 twice. I could cross cancel with those, and then I can multiply straight across. So I have 2 times 2, which is 4, and then I have 1 times 7, which is 7. So when I multiply these two fractions, I just get 4 over 7. But now when we're dealing with these rational expressions, all you're doing is factoring completely, and then you're going to cross cancel. Let's take a look at this first example. So we have x minus y raised to the third all over x plus y. We have times 3x plus 3y all over x squared minus y squared. So let's go ahead and factor out each term, or each fraction completely, the numerator and the denominator completely. Now x minus 3 raised to the third power, I'm going to rewrite it this way. This is just x minus y times x minus y times x minus y. So this is already factored. X plus y, I can't do anything with that. This is just x plus y. Now I have times. And now for the next fraction, the numerator, I have a GCF of 3, so I could factor that out, and I'm left with x plus y. The denominator of the second fraction, I have a difference of 2 squares. That factors into x minus y times x plus y. Now you want to check to see what they have in common. What common factors do they have? And then you could cancel them out. Okay. Well, I notice I have an x minus y in the numerator here, and I have an x minus y in the denominator for my second fraction. I could cancel those out. another factor that they have in common, this whole x plus y cancels out with this whole x plus y over here. You can only cross out one for one. For example, I can't cross out this x plus y as well because I don't have two x plus y's in the numerator. So you can only cancel out one for one. Now that's all the common factors I have. So now let's rewrite our problem. So in the numerator, I'm left with 3 times x minus y times x minus y. And now the denominator, I'm left with just x plus y. Or another way you could rewrite this is 3 times x minus y squared all over x plus y. Either one of these answers is correct. Let's take a look at another problem. So we have a cubed plus b cubed all over a squared minus b squared times a squared minus 2ab plus b squared all over a squared minus ab plus b squared. Okay, so let's try to factor these out. Let's begin with the first fraction. The numerator, this is a sum of two cubes. So I could use my sum of two cubes formula and factor that out. So this would become a plus b times a squared minus ab plus b squared. The denominator is a difference of two squares. That factors into a minus b times a plus b. We have times. Then the numerator of my second fraction, this will factor into a minus b times a minus b. And then the trinomial in my second fraction, by the denominator, a squared minus ab plus b squared, this cannot be factored. So you just leave it alone. Now you take a look and see what do they have in common. Well, one thing I noticed is they have an a minus b in common, so I could cancel those out. Now they have this whole a squared minus ab plus b squared. I could cancel those out with each other. And then I also have an a plus b in the numerator and an a plus b in the denominator, so I could cancel those out as well. So now all that I'm left with, in the numerator I have a minus b, and then the denominator there wasn't anything left. There's really just like a 1 that's left over. So now a minus b over 1, this just gives me a minus b. And now it's completely simplified. So next we go to dividing fractions. Dividing fractions very similar, except you have to remember the property for dividing fractions with each other. You're going to keep the first fraction the same, change division and multiplication, and then flip the second fraction. And then you would work it out just like the previous two examples that we saw. Let's take a look at an example. So divide and simplify. So we have a squared minus b squared over ab divided by a squared minus 2ab plus b squared all over 2a squared b squared. So let's go ahead, keep the first fraction the same. So my very first step, I'm going to change this into multiplication. So first fraction stays the same, change division and multiplication, and then flip the second fraction. And now we have a multiplication problem. So now let's work this out the same as we did with those two other examples. Our first fraction in the numerator, a squared minus b squared, that factors into a minus b times a plus b. The denominator ab, I can't do anything with that, just leave it alone. And now with my second fraction, 2a squared b squared, can't do anything with that one. And now the denominator of my second fraction, this factors into a minus b times a minus b. And now you look for common factors. So one thing I noticed is that I have a minus b in common. I could cancel those out. Now be careful here. A plus b and a minus b, these are not the same. I can't cancel those out. But another thing I can cancel out is I can cancel this a out with one of these in the numerator. And I could also cancel out one of these b's with one of these b's in the numerator. So now I'm left with, I have 2a times a plus b. That's what I have in the numerator. And in the denominator, I just have a minus b. And now, when you're left with this fraction, be careful. You cannot cancel these a's out. Okay. The a in the numerator, that is actually a factor. But the a in the denominator, this is just a term. Okay. So it's not common like factor. This a is a term. The other a in the numerator is a factor. Okay, I can't cancel those out. So you'd have to leave your answer just the way it is. Okay, one last problem. So divide and simplify. So let's go ahead and rewrite this into multiplication. So you have x squared plus 7x plus 10 all over 2x minus 4. And then division, change to multiplication. And then flip the second fraction. And now you're going to factor these out completely. So for the first fraction, the numerator, you need two numbers that multiply to give you 10 and then add up to 7, which is 5 and 2. So I have x plus 5 and x plus 2. The denominator, there's a GCF of 2. I can factor that out. I have x minus 2. And now let's work out the second fraction. Let's completely factor it out. X minus 2, can't do anything with. Now for the denominator, x squared minus 3x minus 10. I need two numbers that multiply to give me negative 10 and then add up to negative 3. So I could use x minus 5 and x plus 2. Okay. Now cancel out any common factors. So I could cancel out these x minus 2's. I could also cancel out an x plus 2. And now what I'm left with is x plus 5 all over 2 times x minus 5. And then you're completely finished. Okay. So main idea in this section, factor completely and then cancel out any common factors as long as there's one in the numerator and one is in the denominator. So that was it for section 5.1. If you have any questions, don't hesitate, just email me and I'll help you out.